We have to find the derivative of each of the following functions. So this is a matter of remembering our derivative rules. So let's start with the derivative of g. So for a, g prime of t. We've got the constant times a function, so the constant carries down. Now we have to remember what the derivative of tangent t is. Derivative of tangent with respect to t is secant squared t. The derivative of a sum is the sum of the derivatives, so we add the next derivative. 7 times e to the t. The derivative of e to the t is e to the t. Minus, now we've got a power rule, 4, and then constant by itself, just 0. Nothing to combine there, no like terms. That's it for part A. For part B, now we have a quotient, so we're going to have to use the quotient rule. If you want, we could avoid the quotient rule by rewriting this in the following way, but I'm just going to do the quotient rule. But you could avoid it and do the power rule and the chain rule instead. That sounds like more work to me. So f prime of x. What's the quotient rule, you ask? The quotient rule is the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. So we've got the derivative of the top is 2 times the bottom, 3x minus 1, minus the derivative of the top, 3 times the bottom, 2x plus 1, all over the bottom squared. Okay, so again, that was derivative of the top times the bottom minus derivative of the bottom times the top all over the bottom squared. Now let's combine like terms. Up top, we've got 6x minus 2, and now we're going to distribute a negative 3. Negative 6x minus 3. I'm going to leave the bottom factored. And now a positive 6x and a negative 6x. Those like terms combined cancel each other out. And then combining those coefficients, those constants, we have a negative 5 divided by 3x minus 1 squared. Okay, let's move on to the last problem, part C. To find the derivative, we've got an x squared function times a sine function. Since this is a product, we're going to have to use the product rule. And the product rule is derivative of the first times the second plus the derivative of the second times the first. So we've got derivative of the first times the second plus the derivative of the second times the first. Now we don't need all these parentheses here, but I'm just doing this to remind us, hey, this is the derivative of the first. Derivative of x squared is 2x. The second function is sine. The derivative of the sine function is the cosine function. And there you have it. If you like, then you can rewrite this 2x times the sine of x plus x squared times the cosine of x. I like writing my sine and cosine functions with parentheses like this to remind myself that this x and this x are the arguments of these two trig functions, and that this x squared is a function that's multiplied times the trig function. So that's also the reason I like to write my x squared in front of the cosine x.